All right, so good morning or good afternoon, whenever you're watching this video. This is Mr. Goyaso, and today we are talking about identifying some parts of exponential functions, okay? So yesterday you should have been kind of introduced to like the basics of exponential functions. Today we're gonna take it a step further and look at two different types, so exponential growth and exponential decay, okay? So our first one we're gonna look at, as y'all can see, is exponential growth. So our general equation is this right here. F of x equals a times 1 plus r parentheses to the t power, okay? And we're gonna identify all of those parts because each of those represents something different. So the first arrow, as y'all can see, is pointing to the f of x, okay? The f of x, that is our output, okay? So when we put something into our function, our output is our f of x. So that's what comes out, okay? The a, that is our initial value. Okay, so that's kind of like our starting point, okay? So our initial value is a. The 1 plus r, so that whole little area, that is going to be, the r. Just the r, that is the rate, right? R for rate of growth, okay? R is the rate of growth, and then t is going to be time, right? And we'll deal with that later. Today, what we're really focusing on is that rate of growth, okay? Next part. So this whole like little 1 plus r, y'all can see that, that is our base, okay? So we don't have a lot of room here, but that is the base, okay? So eventually, it'll be just a b value, okay? But we'll get to all that later. Okay, and then eventually we're going to put it together and it'll look like f of x equals a times b to the x power, where b is greater than 1, okay? This is what means it's a growth. The b is greater than 1. And again, I'll show you examples of that, okay? So let's look at some examples. We're going to write an exponential equation given two things, okay? So given our a is 1,150 and our r, that should be an r, not an f, is 10%, okay? So let's write our general equation, okay? So our general equation up here is f of x equals a times 1 plus r to the t power, okay? So now let's plug in the values that we have. So we have an a and we have an r, okay? So if we plug those in, I get f of x equals 1,150 times 1 plus 10% to the t power, okay? Now, we need to combine our base. We need to combine the 1 plus 10%, okay? Plus our growth factor. So to do that, I'm going to kind of go over here. So we need to know 1 plus 10%, okay? So you could do this in the calculator, or if you remember your decimals, 10%, we can write that as 1 plus 0.10, okay? So if we add that up, 1 plus 0.10, you put that in your calculator, you get 1.1, okay? So when I simplify my base, when I simplify this parentheses, I get my final exponential equation as f of x equals 1,150 times 1.1 to the t power. And that's it. That's an exponential equation with my initial value of 1,150 and my growth factor, my rate of growth as 10%. Okay? Now let's slide over to the next one. So there's number 1. Okay? Number 2. So number 2, my growth, my A is 55. My rate is 13%, okay? So same thing, let's set it up. So I have f of x equals a times 1 plus r to the t, okay? And we're gonna plug in what we have. So f of x equals a, which I have, so 55, times 1 plus r, which is 13%, to the t power, okay? I did not put that little line there, that was an accident, my bad. To the t power, okay? And then, of course, we simplify over here on the side. So 1 plus 13%, or 0.13, remember you move the decimal twice, we get 1.13, okay? So this is my growth factor, okay? So the growth factor is what the b is. So I put that together, I simplify, f of x equals 55 times 1.13 to the t power, and that's it. Okay, pretty easy. Same thing for number 3. Okay, let's set it up. So f of x equals a times 1 plus r to the t power, okay? And again, we're going to substitute in the values that we have. So we have an a and an r. So I get f of x equals, instead of a, I'm going to put 5,000 times 1 plus 27% to the t power, okay? And again, we do a little math off to the side here. 1 plus 0.27, because that's 27%, I get 1.27, okay? So that's my growth factor. So then I write it in, simplify. So f of x equals 5,000, so bring that down, times my growth factor, 1.27 to the t power. And there we go. Okay? So these are examples of exponential growth. And again, they're growth because my b is greater than 1. My b is what's in parentheses here. So if y'all look, 1.1, that's greater than 1. 1.13, that's greater than 1. 1.27, greater than 1. All of these are growths, okay? Now, on the next page, we are going to be looking at the other type, which is decay, okay? Now, it is very similar. There's just slight differences. So let's start about labeling our parts again, okay? So it's relatively the same thing, right? My f of x, that's still my output. A, that's still my initial value. Okay, and my r is now my rate of decay. Because if you remember, it was our rate of growth. But now, since it's an exponential decay, it's my rate of decay, okay? And then t is time, okay? Now, this, in parentheses, right, if you remember on the last page, that was our growth factor. This is going to be our decay factor, okay? So it's still our base, but it's our decay factor if it's, well, I'll show you right down here. So the general formula is f of x equals a times b to the x power, okay? But this is the difference, where b is greater than 0 and less than 1, okay? So what that means is it's a decimal in between 0 and 1, okay? So we're going to see some examples of this, okay? So let's start with number 1. So let's write our example exponential equation given the following information. So it's a decay. My a is 675, and my r is 48%, okay? So set it up the same way. We're going to use our general formula. So f of x equals a times 1 minus r, right, since it's a decay, to the t power, okay? And again, I put in the same information I have, the a and the r. I just substitute those in. So I get f of x equals my a, which is 675, times 1 minus 48% to the t power, okay? So now we do a little math over here to the side. So instead of 1 plus our decimals, we're going to do 1 minus, and then 48% is 0.48, okay? And again, y'all have a calculator. You can type this in. 1 minus 0.48, you get 0.52. So that is my decay factor, okay? So we simplify it. So I get f of x equals 675. And then now my new decay factor is 0.52 to the t power. Okay, and there we go. So y'all can see my decay factor, my b value, this one is in between 0 and 1, right? It's 0.52, okay? It's not greater than 1 and it's not less than 0. It's in between. So this is a decay, okay? Number 5, same thing. So we do f of x equals a times 1 minus r to the t, since it's a decay. Plug in what we have. F of x equals, my a is a big number, 12,500, times 1 minus that should be 18%. Let's change that. Okay, 18%, so 1 minus 18% to the t power. Okay, so we do a little math off to the side here. 1 minus 0.18, okay? Put in your calculator, you get 0.82. So that is my decay factor. It's in between 0 and 1, okay? Simplify it out, write my final answer. F of x equals 12,500 times my new decay factor, 0.82 to the t power. And there we go. All right, last one on this page. So here again, a decay. My A is 5,000, my R is 27%. So same thing, okay? F of x equals A times 1 minus R to the t power. If y'all want to skip ahead, you can. But if you want to see some more examples, keep watching. So now we plug in what we know. So my A is 5,000, my R is 27%. So F of x equals 5,000 times 1 minus 27% to the t power. Do a little math. 1 minus 0.27, put it in the calculator, and you get 0.73. So that's my decay factor. That's my B. So we plug that back in. So F of x equals 5,000 times my new decay factor, 0.73 to the t power. And that is it, okay? So there's 3 examples of exponential decay. And again, you can tell your B value is in between 0 and 1, okay? Compare that to our first examples, right? Our growths, our growth factor, our B, was bigger than 1 each time, okay? So now what we're gonna do is we're gonna use what we just learned and determine if these examples are growths, decays, and then some other parts to them, okay? So, number 7, we have the function g of x equals 234 times 1.56 to the x power, okay? First thing we want to know, is this a growth or decay, okay? So to determine that, we look at our b. We look at what's in the parentheses, okay? For this one, my b is 1.56, right? So that is going to be a growth because my b value, the number right here, is greater than 1, right? 1.56 is greater than 1. So this is a growth, okay? And how did I know that? You can just write this, b greater than 1, okay? Saves a lot of time. My initial value, my a, remember, is what's in front of the parentheses. So in this case, 234, okay? Your rate, your r, okay? So remember, it was 1 plus whatever my rate was, right? So if my growth rate is 1.56, that means my rate, so to find that, we did 1 plus 0.56, right? That's how we got that. Now this, we want to change it back into a percentage, so you just move the decimal 2 to the right. So that means my rate is 56%, okay? So it's just 0.56, so the growth rate is 0.56, 56%, okay? And the y-intercept, okay? So this is actually really easy. All you have to do for the y-intercept, first thing, remember, when you're writing your y-intercept, your x value, it's always 0, every single time, okay? Then you just need the y. Where you get that from is your initial value, okay? So if my initial value is 234, my y-intercept is 0, 234, okay? And that's true every time for these exponential problems, okay? So that's number 1, or sorry, number 7, done. Number 8, okay, so number 8, I have the function h of x equals 41 times 0.8x, or sorry, 0.8 to the x power, okay? First thing, growth or decay. So we need to look inside the parentheses. Is this value greater than 1 or in between 0 and 1? Well, hopefully you could tell. 0.18 is in between 0 and 1. So that means it's going to be a decay, right? Because it's in between 0 and 1. It's just a decimal. Okay? So this is a decay. How do I know that? Because B is in between 0 and 1. it's greater than 0, less than 1, okay? That's it. Initial value, that's the number in front of the parentheses, in this case, 41, okay? My rate, this part is a little bit trickier, okay? So my rate, remember, it's for decay, it's 1 minus r, okay? And in this case, my 1 minus r was 0.18, okay? So, to find that r, okay, this is what you're going to do. You're going to subtract the 0.18 from 1, okay? So it's kind of like the opposite of what we did before, okay? So 1 minus 0.18 gives me, like that, this is what I'm saying. So 1 minus 0.18 gives me 0.82. So that is my rate. That's my decay rate, okay? My rate of decay, sorry. So it's 82%, okay? So if it's a decay and you want to find the rate, okay, you just do 1 minus whatever's in here, okay? So 1 minus 8.18 is 0.82, which is 82%, okay? And we'll look at that again, so hopefully it'll make a little more sense, okay? Y-intercept, same thing as before. So if my initial value is 41, my y-intercept is 0, 41, okay? That's it, every single time. So your initial value and y-intercept you should always get, okay? Number 9. So number 9, I have 1,050 times 1.95 to the x power. So again, growth or decay, we look at what's in the parentheses, 1.95. That's clearly greater than 1. So that's a growth because my b is greater than 1, right? That's my b. The initial value, what's in front? That's easy, 1,050, okay? Which means the y-intercept is 0, 1,050. We can skip ahead there. And then the rate, so remember, for the growth, it's really easy. So we have 1.95, so it's just whatever that decimal is, right? So if it's 1.95, right, it's greater than 1. So how much greater than 1? 0.95 greater than 1, which is 95%. Okay, hopefully I'm catching on to this. And then number 10, last one, okay, promise. We have g of x equals 37.50 times 0.3 to the x power, okay? So, first things first, look at your b. Is that greater than 1 or in between 0 and 1, right? 0.13 in between 0 and 1, that's a decay. And I know that because I just said it, right? b is in between 0 and 1, okay? Initial value, super easy, number in front, 3750, which means my y-intercept is 0, 3750, okay? And now this is probably the trickiest part, the rate, okay? So to find the rate, remember what I said. When it's a decay, you do 1 minus whatever's in that parentheses, okay? So 1 minus 0.3, that gives you 0.7, which is 70%. So my rate is 70%, okay? And that's it, okay? So those are our notes for today. So if y'all have any questions, feel free to ask your teacher, but that's all I got. Y'all have a great day. See y'all on Zoom.